Clustering techniques. This clustering is a machine learning technique that groups similar elements together, and it is a way to find patterns in data without using label example. Think of it like organizing item in a closet where you group similar items together, like all your blue shirts in one drawer and your black pants in another. So imagine you have a bunch of data points such as customer information, which include their age, income and purchase history. So here the clustering technique will help you group these customers into different segments based on their similarities. For instance, you might group customers who are young, have high income and frequently buy luxury items in one cluster, while another group would consider of older customers with lower income who primarily purchase affordable items. And there are different types of clustering algorithm. First is the k-means clustering. This clustering techniques come in different flavors, and in this k-means clustering, it works by dividing your data points into k cluster, where k is a user-defined parameter. And this algorithm then iteratively moves the data point to the closest cluster, recalculates the cluster center, and repeat the process until the cluster no longer changes significantly. And this technique is computationally efficient and works well for large data set. So example, imagine you have a data set of customers with attributes like age, income and purchase history. So here this k-means clustering would group customers into k clusters based on these attributes, which help you identify distinct customer segments and tailor your marketing strategies accordingly. Then we have hierarchical clustering. This hierarchical clustering will create a tree-like structure by repeatedly merging the closest cluster, which results in a dendrogram, which can be used to visualize the relations between data points. And this hierarchical clustering can be agglomerative, that is merging clusters, or divisive, that is splitting cluster. And it is a flexible technique that can handle varying numbers of clusters, but it can be computationally expensive for large data set. So consider a data set of product with attributes like price, features and popularity. So this here hierarchical clustering would group similar products together, will create a dendrogram that shows the relations between them, which can help you identify product categories and subcategories for better organization and marketing. Then we have density based clustering. So this density based clustering will group the data points based on their local density, and it works by defining a neighborhood around a data point and expanding the cluster if there are enough points with high density. And this technique is robust to noise and outliers, but requires the setting of parameters like the neighborhood radius and density threshold. For example, imagine you have a data set of locations with attributes like latitude, longitude and population density. So here this density based clustering would group densely populated areas together and will identify sparse regions as outliers, which can be useful for urban planning, identifying areas that require additional resources, or designing targeted marketing campaign. Then we have spherical clustering. So spherical clustering is somewhat similar to the k-means, but it uses a spherical distance matrix instead of Euclidean distance. And this technique is useful when data points are distributed spherically around the cluster centers. For example, we consider the data set of stocks with attributes like daily closing prices, volume and return percentage. So their spherical clustering would group stock items with similar price trends and marketing behavior, which will enable you identify patterns and trends in stock markets. Then we have hierarchical density based clustering, so which combines the strength of hierarchical and density based clustering by creating a dendrogram that represents the hierarchical relations between data points while also handling noise and outliers. For example, imagine you have a data set of customer reviews with attributes like sentiment, sentiment intensity and product category. So their hierarchical density based clustering would group reviews with similar sentiment scores and product categories, which will allow you identify patterns and trend in customer opinions across different products. Then we have clustering with constraints. Now this allows you incorporate additional information or prior knowledge into the clustering process, and this can be achieved by incorporating constraints like cluster cardinality, cluster proximity or cluster dissimilarity. And it can be useful when you have prior knowledge about the structure of your data. For example, suppose you have a data set with attributes like age, gender and interest, and you want to create clusters that are roughly balanced in terms of gender. So this clustering with constraints would ensure that each cluster has a similar number of male and female users, which will allow you to design targeted marketing campaigns that are sensitive to gender specific preferences. Then we have mixture models. Now, these mixture models are probabilistically clustering technique that assume the data points are generated by mixture of multiple Gaussian distribution. So here this expectation maximization algorithm is used to estimate the parameters of this mixture models. So for example, imagine you have a data set of customer reviews with attributes like sentiment, sentiment intensity and product category. So there the mixture model would group reviews into clusters based on the distribution of sentiment scores and product categories, which can help you identify distinct sentiment patterns across different product categories, which can inform your product development strategy. Then we have topological data analysis, which is useful when dealing with irregularly shaped clusters, high dimensional data or non-Euclidean distances. For example, consider the data set of protein structures with attributes like atomic coordinates, protein-protein interaction and protein function. So there the topological data analysis would identify cluster of protein structures that are similar in terms in their structural and functional properties, which can help researchers identify protein families, study the evaluation of protein structures or design novel drugs. So whenever you are applying any clustering technique, say for financial application, first we need to install the scikit-learn. Then we need to use the data set, say we use the stock market data, and then we'll load the data, we'll perform some data processing. If we use k-means clustering, then we will define the number of clusters, and then we will initialize that algorithm, will fit the data and will inspect the data. And then we can add more features while experimenting with different values of k, and then we will visualize the clusters using different techniques. So that's all for today. Thank you.